So we're going to talk about what it's not switching. The slide's not switching there. OK. We're going to talk about, first of all, what does it look like in a cloud-focused world? What's changed? What is the primary hurdles we're trying to overcome? What's our solution, or what we see as a solution for this problem? We'll talk a bit about how Nutanix is managing their observability full stack, end-to-end, in several different applications, and a bit about the path we're seeing in the next few years. So first interesting fact is that about 7 to 10% of cloud costs are observability spend. That can be CloudWatch, that can be your external vendors, that could be your compliance data if you're a fintech and you have reasons to store data for a longer period of time. And what we found is that a lot of that spend is actually storage, which is one of the hardest components to optimize in the cloud, besides very aggressive data compression, which causes some performance issues. And what happens is that you can optimize CPUs, you can optimize spot instances, you can optimize even from the way you procure, so if you give commits and so on. But the storage part remains extremely expensive, slow, and hard to scale. And observability data is accelerating. There are a lot of good factors that are happening throughout the past years. First of all, it comes baked in. Most platforms expose, whether it's logs, metrics, traces. OpenTelemetry is making huge changes now in how software is being even deployed and delivered. Most software components, most new open sources are going to implement OpenTelemetry, which is now actually supporting both logs, metrics, and tracing data. And so there's finally a way to actually implement a single point of integration and then be able to use the different contribs and send data to different providers. So if a while back, or not too long ago, you had to use a proprietary agent, and then every change, every switch would have been a pain. Now it's much easier, which is great for us. The data is very consistent. There are structures that we're working by. If we look at log data that we've seen, so Coralogix has been existed since 2015. If we look at the data that we've seen even back then, 2015, 16, 17, and today's data is a lot more structured, a lot more optimized, it's a lot more readable. And it's mostly available via API. You don't have to go to the machines, or you don't have to collect whether it's the logs or the traces. Everything is easy to pull. And in terms of storage, which was always a problem, you have infinite storage. And you have different tiers of storage. You can put it wherever you want. It's durable. That's great. So if your problem is storage and retention, that problem is basically solved by your cloud vendor. But we have a lot more data to track, and we have a lot more issues to track. So machines don't last for long, and sometimes the only evidence you have of a problem is the log data or the metrics that machine or that function or that container had left. Number two, systems become more distributed. Now, it's great that you have a distributed system. The problem is that if you really want to keep track of what's happening in that distributed system, you've got to track internal logs at every service, and then also the interfaces between the services. So services are very chatty, and you want to actually track every request response you got to be able to identify and isolate a problem. So systems are more distributed. We have to use more telemetry data to understand what happened. We don't have that physical anchor that we used to go to that machine and actually check what happened there. And there are just a lot more moving parts. We're using a lot of third parties, a lot of open source solutions. And in previous years, the ability just to instrument something into your code and then extract, the printfs or whatever you want to understand structure of data, what's happening, or get to the specific line of code that generates a problem, which is still great, and some products do that, and it gives value. But today, a lot of companies, half their production or more is third parties, APIs, open source tools, infrastructure that they don't manage, or even serverless computing. And then you don't have that way to actually instrument into that code, and you have to rely on the metrics, the logs, and Amazon is, for instance, a great example for a company that does a lot of efforts to implement easier tracing and tracing telemetry into their serverless components. So generally, I described a few issues, but the main factor that is affecting everything is the data volume. We have massive data volumes, and in Coralogix, our motto is data grows faster than revenue. Whatever your company is growing, however successful your company is, data is going to outpace that. And it's something interesting to think about. Observability data sits on one of the most expensive expenses that your organization has. Observability data is part of the cost of goods, the cost of doing business. And so it's counted for the company's margin, the gross margins. And companies are valued by their gross margins. So if you start spending too much on data for monitoring and observability and performance, you're actually touching one of the most expensive budgets in your organization. And so a few things that work actually in our favor, but we're not really using. One, 99% of data is never searched. We know that. We have 2,000 customers. We digest over a petabyte of data every day. We store tens of petabytes for our customers. We know 99% of data that's stored is never searched. We know what we display and what we don't display. 95% of errors are produced by 5 templates, which is insane. So Coralogix has this feature called log aggregation that automatically clusters data by the type. So it'll identify the branch of the data, the structure of the record, and then get into the inner message and understand what are the variables and what are the constants, and cluster data by its types. Everything happens in the stream. We'll talk a bit about the architecture, but what's important to note here is that when we run statistics on our templates database, we notice that just the top 5 errors in, first of all, entire production, all customers multi-tenancy, but also per customer, are generating 95% of errors. Think of the amount of time and noise you have to sift through when you're isolating a production issue and you see all these known errors, good errors, not really errors. Those things are, first of all, blinding you. Second of all, are considered high-value data that you're paying a lot of money for, but that doesn't really have any benefit. And then that one is really interesting, and we're trying to educate a lot of times our customers. A lot of customers will come in and say, we need 30 days retention, we need 90 days retention, we need a year worth of retention. This stat is pretty insane. 99.99% of queries don't cross the 7 days mark, besides dashboards and aggregations. And there are other ways to solve dashboards and aggregations. Raw data for over 7 or 8 days is rarely queried. And then yet, we pay a huge premium to keep that data. And there's an important distinction also to make here. Us as a vendor, or any other observability vendor, we have 0 value in retention, okay? We analyze the data, we index the data, we route the data, we give you alerts, we give you insights, we let you search the data, we let you visualize. When you just ask me for more retention, what I do as a vendor, I buy storage, basically, from Amazon, and I'm a SaaS company. I need to operate at like the 60, 70, 80% margin range, okay? What I do, I buy storage, I mark that up 70%, and I kind of sell it to you back. So I'm acting as the worst cloud reseller in the world. Basically, this is what you're doing when you're taking a long retention. But yet, sometimes you need that 0.001 query because it's that customer, it's that critical issue. So how do we actually deliver that without having the pain of paying 3, 4, 5 times more? And this one is also very interesting. You can drop, and again, we've done this cross clusters, cross multi-tenancies, and per customer. So whether group buy or not, you can drop today 30% of your data and never notice it, okay? And that drop could be full applications, full specific severities within applications like debug or verbose, specific logs that you match by regular expressions or metrics that you drop by regular expressions or by labels that you don't really need, or specific keys within a record that you don't really need. And so many keys are just multiplied over and over. Like timestamp is always multiplied. Server name and instance name, we always see that within the data. There's a way to actually drop 30% without damaging any observability you got. So when you look at an organization, and this is supported by public records of public companies operating in the data space, you look at a company, phenomenal companies like, I'm mentioning competitors, but they're worth it, Datadog or non-competitor Snowflake. These companies actually publish that their net retention rates are, let's say, 140 for Datadog, 170 for Snowflake. If a company has 170% net retention in the world of KPIs, that means that an average customer would pay year over year 70% more than he started with, okay? Now, investors really like that, right? You get more money from the customer, you're probably a great product, which is probably true about Snowflake. But then if the average customer pays 170% year over year, what does that mean when you sign a contract about your bill 3-5 years from now? Is that even sustainable? So we feel that it isn't. And that's why our approach is we have to break down the need for storage. And we have to start analyzing everything in stream and only store what matters and store it in a remote archive that, first of all, isn't ours, so we don't have to do that storage reselling. And second of all, is the lowest price possible archive. In our world here, Amazon, it'll be S3. So, and S3 is different tiers. So what does that look like from an architectural point of view in Coralogix, for instance? Coralogix's core is based on Kafka streams. There are several Kafka clusters. The first thing that we do is the ingress service will validate the data, put it in Kafka. Kafka will replicate it. So we have it persistent. And then each and every of our microservices is actually capable of extracting only the relevant state from the record and putting it in an embedded DB. We use RocksDB for that, but you can do other things. And we use hyperlog to have a very low memory footprint there. So whether it's parameters we know that are interesting, for instance, counts per application, counts per subsystem, different labels, cardinality of keys, high severity ratios, things that we know that are always interesting. Or your user definitions, that can be parsing rules, enrichments, that could be alerts that you define. We sync everything into the stream. We never, when an event enters a Kafka stream, it never leaves it until it's fully processed. And so the mechanism we've invented here is called the 3S, store, stream, and sync. So you define anything in external, or let's say it's a machine learning model that we run in batch. We sync it into the stream, an event enters the stream. It's fully processed without leaving the stream, so we have no side effects. It's all about CPU, no memory, no network, no external dependencies. Even if MySQL dies or my Redis dies completely, events will continue streaming. It's just no new updates will be entered, which touches on another very big pain point of observability. So we're talking always about price, performance, and scale, and basically stability. So hot storage is just one of the options, but the default option will be the S3 bucket. To complete that streaming component, we created what we call CX data. CX data is the Coralogix format for archive, which is dynamic per K, okay? Dynamic per K, and you can do that post-processing. You don't have to use Coralogix to do per K. Just for logs, they tend to be very dynamic, and the amount of keys doesn't allow you to do post-processing with Spark and rewrite it and restructure it as an index. So we write per K, and then we query it from remote at high speed. We have some sort of trick to do a level of inverted index there. And we're able to scan, let's say, 10 terabytes within 30 seconds. So that's our approach there. And when you don't depend on the storage, what you do, you extract the metrics you need with the labels you need for long-term visualizations. So you basically preset all the aggregations you can think of, and you turn your logs into metrics. Metrics don't need to go through that process. Metrics are analyzed in the stream for alerts and then kept in the archive and PromQL format, not the Parquet. And then you analyze all the alerts and all the things that the customer cares about. You stream it into a live view, and then you put it in an archive that he can remotely query. So we answer in real time, high speed, zero latency, the known knowns and the known unknowns. For the unknown unknowns, you'll have to pay a little fine of querying the archive. If it's data that you know that has a lot of unknown unknowns, like errors, like your P0 applications, you'd put that in the frequent search, that hot storage, typically about 20-30% of the data. And that data will be even faster because those indexes don't do anything besides the user queries. They don't do alerts, they don't do aggregations, they don't run the dashboards. And so Nutanix, and Mukesh will share more of their story here, what they've done with Coralogix, migrating from one of the larger vendors for logs, metrics, and tracing, 60% of the data is never indexed. It's never stored. So they're gaining top performance, infinite retention. They save about 40% of their TCO. And all the visualizations and alerts are running in-stream real time. Data clustering and automatic version benchmarks, all of these are features. But there's, again, one distinction that we made internally, and vendors need to be honest with themselves. It's really easy to kind of fall in love with features and machine learning algorithms. But at the end of the day, an observability vendor is selling infrastructure. So when you look at observability vendors, and also cloud vendors to some extent, what do you care about most? You care about performance, speed, compliance, stability, and price. Every other features are great, but those are nice additions that'll help you choose. But at the end of the day, if it's stable, compliant with what I need, give me the performance that I need, and has the best TCO possible, that's probably my main decision factor. Let's hear a bit about Nutanix. Mukesh will talk about the business and how Nutanix is running their infrastructure today.
Thanks, Ariel. Hi, I'm Mukesh Bafna, software engineer at Nutanix. Happy to share Nutanix story of leveraging Coralogix for its SaaS applications monitoring. Firstly, I'll provide overview of Nutanix, then Nutanix Insights overview, and how Nutanix Insights is using Coralogix for its observability. Nutanix was founded way back in 2009. It was founded with a mission of bringing public cloud-like capabilities like simplicity, web scale elasticity, and agility to customers' on-prem private data centers. Nutanix came up with hyper-converged infrastructure that converge compute, storage, and networking into commoditized x86 hardwares. Now, it also allowed you to add new x86 servers to increase compute, storage, or both of them independently, depending upon your use case. This eliminated silos and inefficiencies that exist in typical three-tier architectures. Nutanix continues to be leader in HCI through Magic Quadrant of Gartner Magic Quadrant and Forrester reports. Now, Nutanix has, in last 12 plus years, Nutanix has continued to progress on its mission of simplifying IT infrastructure by now moving to multi-cloud and hybrid environments. Nutanix data services like file storage and object storage are in visionary quadrant in Gartner's Magic Quadrant for second consecutive years. Nutanix has large customer base, including Fortune 500 customers. We are about 6,000 plus employees at Nutanix. Another important aspect about Nutanix is we have 90 plus NPS score for last 7 plus years. Now, we are able to maintain that NPS score mainly because we have high quality product and high quality support and support automation tools that help us solve customer issues proactively and faster. Double-clicking more on what Nutanix offers to customers. Nutanix offers its customers choice of server platform they want to use. Some customers want to use a particular server platform because they have good relations and they can get better discount from the server platform. Whereas some customers want to standardize on particular server platform because of compliance reasons, right? Nutanix supports all of the main server platforms and major cloud vendors. Nutanix can be installed on the customer choice of hardware, and once enabled, it provides simple, unified cloud platform that is hybrid multi-cloud and with rich data services to run, build, and manage any kind of applications. Today, Nutanix runs many mission-critical applications. It also runs a lot of modern Kubernetes-based applications. It runs VDI application, database applications. And a lot of our customers are using Nutanix to seamlessly migrate workloads in and out of cloud. So that's what Nutanix brings to the table. Now I'll provide more context about Nutanix Insights, which is an predictive health and support automation service. This service brings 3 key values to Nutanix customers. First, actionable discoveries. Nutanix discovery engines uncovers cluster health, availability, and performance issues across all of the customer deployments and present them to customer in actionable format so that they can address those issues quickly. Nutanix Insights provides single pane of glass, meaning it is tightly integrated with Nutanix Support Portal, providing you unified health view across all of your Nutanix deployments, spanning across data centers, spanning across sites, geographies. Smart support is another aspect where Nutanix Insights automates a lot of mundane support workflows in order to speed up resolution of customer issues. Example would be opening a support case, doing a remote log collection. Now I'll briefly explain the end-to-end workflow with Nutanix Insights. It all starts with customer enabling Pulse service on their customer Nutanix deployments. Once they enable the Pulse service, those Nutanix deployments start sending configuration, logs, different kind of system diagnostics, health metrics related data to Nutanix analytics pipeline. Once it reaches Nutanix analytics pipeline, it can process, transform, enrich, and store data in data warehouse. That is then used by analytics services that are running on cloud to generate insights about different issues that customer deployments might have. It generates those issues depending upon learning from other customer support cases, from best engineering practices, security vulnerabilities that might have been discovered. So it presents those health issues to customer in an actionable format. Customer, and it also many times opens the automatic support case so that we can engage with customer to solve those issues very quickly. It also does remote log collection if required, and at the end, the circle completes when the issue is resolved at the customer's deployment. A simple example simple real-world example to explain that would be, consider a case of power supply failure on the server. This could be, this could bring down the application if the other remaining power supply also fails at the same time, right? So as soon as these signals are received on the analytic pipeline, it will create a support case, notify customer, and also ship the replacement hardware immediately to mitigate the risk. That's how Nutanix Insights works with customer in order to keep their environment healthy. Now this diagram explains high-level data flow workflow of Nutanix Insights. You have 60,000 plus Pulse-enabled clusters streaming data continuously to Nutanix Insights pipeline. All of this data hits AWS application load balancer. From there, it is redirected to different set of receivers depending upon type of data. Now, these receivers are stateless Kubernetes service running on Amazon EKS. We have, at any given time, we normally have around 20 plus receiver instances running at the same time because of the sheer load of the data. Then the job of this receiver is to receive the data from the client, to uncompress it, validate the data, and batch put this data on Kinesis for cost performance reasons. Then we have set of bunch of consumer lambdas. These consumers are implemented as AWS Lambda functions. At any given time, there will be hundreds of instances of consumer Lambda running. These Lambdas will pick up data from these Kinesis data streams. Then it will do more detailed data validation, schema validation, data cleansing, data parsing, data transformation, data enrichment, and at the end, it will put the process data onto Nutanix Insights, put the process data onto persistent storage. And this processed data can also get ETL to different other storages for different use cases. This process data is made available to different applications using API gateway. which is again implemented as a Kubernetes service, serverless, stateless service, and running on Amazon EKS. Then we also have batch job running on AWS EMR that processes more historical data in order to generate insights or health issues of customer deployments. We also have other consumer application processing data, consuming data and generating insights. So overall, we have this big data pipeline running on AWS, and we were looking for a monitoring solution. We had a monitoring solution, but we had two different kind of monitoring solution. We had one different solution for logs, and we had different solution for metrics. And that was one of the problem. We wanted a single observability solution for all of our observability data. Another problem was our metric solution was really costly. We were looking for a solution that helps us reduce our observability cost. That's where we started exploring different options. We had an idea about a set of high-level requirements that we were looking from our observability solution. Some of these are outlined here. We wanted an open source based solution purely because we did not want to get into vendor lock-in. Tomorrow we should be able to switch in to another solution if their need arises. And we were looking for SaaS solution mainly because all of Nutanix Insights observability data resides on AWS. And we wanted preferably all data to remain in the same cloud. We wanted a single observability for all of our observability data so that we can correlate and solve complex issues. It should support typical notification systems that we had at Nutanix already. We had use cases to push data directly to Coralogix. So we wanted an open standard-based API to push data to Coralogix directly. And we also had use cases where we wanted to develop tools by pulling data out of Coralogix, mainly developing failure analysis tools to automate some of the failure analysis. We were looking to have integrate our build systems in order to find, quantify our release quality, and also find release over release regressions using observability tool. Support for 24/7 support at no extra cost. Reason being, we had already built dashboards, alerts on existing monitoring solution, and we wanted to move them to a new solution. So we were looking for active support in order to help with that. And all of this still with lower TCO than existing solution. That was our primary requirement. So we did few POCs, and at the end decided to go ahead with Coralogix. And this is how we ended up shipping our observability data to Coralogix, right? So we mainly have Kubernetes-based applications. For logs, we are shipping those Kubernetes-based application logs via Fluentd to Coralogix. For Lambda-based applications, we are using Coralogix Lambda extension to ship those logs to Coralogix. For metrics data, for Kubernetes services standard metrics, we are using open source exporters to move metrics to Prometheus, and then Prometheus is doing remote write to Coralogix. For AWS managed service metrics, we are pulling them via AWS CloudWatch, and then AWS Firehose is putting that data into Coralogix. Tracing, as of now, we are not sending much of tracing data. That is still work in progress. So overall, this is how all our data ends up in the Coralogix. Then we are using Coralogix Logs browser for logs exploration and log visualization. We are using Coralogix hosted Grafana for dashboarding and metrics browsing. And we are using typical email, Slack, and OpsGenie for our notification management. So we have different kind of environments. Like we have production, we have stage, we have QA, we have development. And we only wanted to use critical applications, prod applications data to high tier, because we only wanted to pay premium for application that matters most and where we need more observability. That's where we only send those data to high tier of Coralogix, and all other environments data we send to observability or archiving tier. Right. So now to summarize, with Coralogix, now we have a full stack observability, one solution to observe all our observability data. And to continue on earlier point, we have got better observability with Coralogix, especially around logs. With Coralogix logs template feature, we are able to reduce noise and also reduce inefficiency in our application logging, reducing our log volume overall. And also, various dashboard, logs-related dashboard help us uncover critical issues faster. Then we also are able to set alerts on all kind of observability data, metrics, logs, tracing. And we are also able to set alerts on complex issues like using flow alerts, where flow alert is something where you can have alerts set on 2 different kind of alerts, right? So that has been another good thing we have been using. Open standard-based integration allows you to avoid vendor lock-in and develop tools that could be reusable in future also. We got 24/7 support, and Coralogix support was outstanding, helping us migrate our existing metrics dashboards onto their platform. Their in-app support is also outstanding. Usually, we get responses within a minute. And lastly, and more importantly, we have full-stack observability solution with lower TCO, which was our one of the major goal. Right. Thank you.
Thank you very much, Mukesh. So, a bit of a wrap up to a lot of the things we discussed and some observations we've made along the way. And first of all, when we look at the concept of analyze in stream and query from remote, it kind of, when we started this, we thought, how come no one's thought of that before? And I think a lot of the things that other vendors try to do, or other companies, not even in our space in general, in data try to do, they try to go to lower tier storage and basically impact the level of service that their customers are getting, because there are some things that can't run on the archive. So I'm good with an unknown query running on something that happened a week ago, running from the archive and waiting a minute. But what do you do with the high frequency, high concurrency queries like alerts? What do you do with dashboards that you need to visualize for long term? And then once we are able to separate the two, those two can coexist. High frequency, high concurrency queries together with ad hoc, complex, long-term queries. When you separate the two, you're kind of succeeding to overcome this challenge of data growth and spend, and of course, performance and stability. Just like Mukesh said, one of the other concepts that we were considering when we started Coralogix and we're suggesting our customers to always look at is, how do you avoid vendor lock? Because I might be wrong, not in the sense of that the product isn't good, but maybe our approach to data growth wouldn't hold for 5, 6, 7, 10 years. We are pretty sure that the other approaches won't work for the next 5, 6, 7 years. How do you don't create a situation in which the data collection layer and data visualization layer are creating a vendor lock that'll be very costly to displace, or creating dependency between your organization, because essentially observability is part of your product. And if you are bounded to an external vendor, then you are bounding yourself to their constraints, and you're bounding yourself to their price, and you're bounding yourself to their advancements of technology over the years. And so being able to keep the collection layer and the visualization layer agnostic and just do the heavy lifting, the data analysis with a vendor is something that gives you a lot more freedom. And we like to tell our customers, our vendor lock is our pricing and our service. So, if you want to pay 3 times more, you can do that, but that's my vendor lock. It's not going to be technology or any kind of dark pattern there. We're an advanced technology partner of Amazon. We have DevOps competency, SRP program. We can be procured through the Amazon marketplace. And just one example for a concept of alert that is driven by this in-stream analysis and stateful streaming concept to kind of explain everything together. And Mukesh mentioned the Nutanix usage of flow alerts. Flow alerts is a concept that we created that allows you to create an alert that is composed of a sequence of events over a very long period of time, can be even a few days, of different data types, and the conditions between them are end or end then, okay? Now, why is this so complex? When you run a query like this, and you need to check over a course of 7 days, and you need to check 4 or 5 or 6 criteria every time, and you want to check that every 5 minutes or every minute, the ability of a storage to actually contain the amount of CPU and memory you need, or the amount of resources you need to fulfill this query without reaching starvation, without losing alerts, without getting to backlog is very limited. But when each and every of these alerts is calculated in the stream, and only its state is lasted, and then there's another embedded DB that only gets the hits of alerts, and there's another process that only checks that embedded DB to see if the sequence occurred or not, then suddenly it's possible to say, we've seen a value that we haven't seen for 3 months, and the ratio of errors is over 10%, and within 12 hours, the ratio of buyers on our website dropped. Those things are critical business issues that can be tracked down all the way to the infrastructure. And the only way to do that is, one, to have a single store for everything, or a single stream that analyzes everything. If you think of existing products or even homegrown solutions, you have the logs will exist in a specific database, and then the metrics will be in a different format, a different database, and then the tracing might be someplace else. And then the long-term security stuff will be someplace else. So here, everything happens in the same stream. There's no limit of cardinality. There's no limit of course, there's a limit, but it's pretty high. There's no limit of how stateful an event or an alert could be. So this is just one example on how this approach not only brings the key things, by the way, which is performance, scale, cost, and stability, but also brings better features, better value to the customer at the end of the day. And then the archive query is something that we kind of skipped upon, but we're seeing concepts. What Elastic did in the index world, all Elastic's claim to fame is the dynamic mapping. To be able to send dynamic data and dynamically map it to types and dynamically map it without defining an index. That's great for a hot index, but those indexes are very expensive, both by CPU and memory and the disk that typically is, at least for the short term, required to be SSDs. So we've found a way now to do inverted index and columnar DBs dynamically into the customer's own remote storage, this case S3. So basically, defining a new dynamic mapping now for archive data. And then how do we query that? We're one of the largest contributors now to a very interesting project you guys may want to get to know, which is called Apache Arrow for data fusion. We've contributed a lot there. We're relying on it. And when we need to scale beyond that, we kind of flow into Athena. And to support that even further, so we support several syntaxes in Coralogix. So several dashboards. There's RUI, Kibana, Grafana, Open Dashboard, Jaeger, Tableau, and others. There's always also several syntaxes. We want to give the customer as much freedom as you can. So there's Lucene, PromQL, SQL, and we wanted regex, and we wanted to find another one that'll kind of extract the power of long-term archives, and we created CX Data. Data Prime. Data Prime is a pipeline search, like a flattened SQL. It allows you to do anything you'd like. And then the freedom that it gives the customer lets him do things that are not specifically even observability. Log data, in general, contains a lot of very important business information and security information, but it's parsed and built to serve the observability teams. So when you have another syntax that can restructure it in the stream or rebuild it in the stream or do joins or other extractions or calculations, suddenly more people within the organization can join and enjoy the data that the systems produce. That is it, and we even left you with like 15 minutes extra. So if there are any questions, happy to answer, and if not, thank you very much for